Hello, my name is Tech Lee, one of the authors of these papers. Let me start the presentation. Introduction. First of all, let me explain the study background. This study deals with patients suffering from mental disorder, especially depression. There is a period about these patients' symptoms getting worse, which is called episode period. For example, depressive episode is a period in which overall mental and behavioral changes occur along with a decrease in mood. The term episode means there is a clear distinction between when symptoms are present and when they are asymptomatic. Because episode is a distinguished important period that we must pay attention, there is a need for predicting the episode period. I think available reliable data is digital phenotype data, which is collectible from wearable devices. With data analysis, we can see through patients' condition in daily life, and we can tell them what is a bad habit and what is a good habit for your mental health. Goal of this paper is to test and validate the research hypothesis. We think it is possible to predict whether or not there will be an episode in near future of depressed patient using lifelog sequence data, which is time series data, uh, and collected from digital devices sensors. We use the hidden Markov model. Data collection. Here is a summary of data we used in our study. We only concerned about major depressive disorder patients in data collection. We collected data from 224 people for total period of 1,590 days. From sensors of smartphone and activity tracker device Fitbit, we extracted several features such as light exposure, sleep, activity, and circadian rhythm parameters. For model training and evaluation, we collected ground truth data, the labels on episode event when they suffered from episode. From doctor interview, we could get the labeled information of episode periods. There are representative four categories of observable features that we used in modeling. Each feature has the quantified score value. First, light exposure. This is measured from the smartphone illuminance sensors. As much light as possible in the morning and during the day, and less light at night, patients get a higher score. Second feature, sleep. This is measured through an activity tracker worn on the wrist. The higher the sleep efficiency and the sufficient amount of sleep, the higher the score. The user can get the highest score. Third, activity. This is also measured feature from activity tracker. The more you walk during the day and the less you walk at night, you can get the higher score. Circadian rhythm. This is the last features. To measure the rhythm, we focused on heartbeat ratio, beat per minute. The pulse is sampled from an activity tracker for 24 hours to infer a trend line of a cosine curve. And the score is given by measuring how much the parameter acrophase. Acrophase means a time point where the rhythm curve makes a peak. For example, if the acrophase has shifted from the average, the score is not good. For example, in person who leads an extremely out of rhythm lifestyle, such as napping and nocturnal activity, Probably a crow face will be severely misaligned. Construction of hidden Markov model. We made two HMMs. One is a PHMM, trained with samples from positive days, that is, from episode period. The other one is NHMM, trained with samples from negative days, that is, normal days without episode. For given t, given time point t, if there is any episode event during the days from t to t plus 3, this area, then we mark this case is positive, and this is the training case of PHMM. The training data observation sequence of pictures are collected during this observation period, 2 weeks, past 2 weeks. And by sliding this time point t, we can correct many observation sequence cases for model training. Each element O, consisting of the observation sequence, has 81 different cases because four features have three levels individually. Let's say each feature score has three levels named alphabet H, M, L, respectively. It means high, medium, low. Then, with the definition, we can translate the feature time series data into word sequence like this. In the process, the words, these kinds of words are changed into a unique number of vectorization. Experiment and result. Here is the hypothesis we want to verify in this study. We believe it is possible to predict the occurrence of an episode in the next 3 days with using the feature sequence observed in the past 2 weeks. Therefore, we conducted the following experiment with PHMM and NHMM models. For a given observation sequence O, like this, we need to check if probability of PHMM of O is larger than probability of NHMM of O. If this condition is true, based on the past 2 weeks observation, we can say the given for the given observation, we can say an episode is likely to occur within 3 days from the date t, and in the opposite case, the next 3 days are likely to be euthymic normal days. Table 1 shows the result of evaluating the model performance, precision, recall, and F1 score used as a performance evaluation metrics. The prediction accuracy of the model was 73%. For the negative test cases, the model performed quite higher. Here, 83%. But for the positive case, it showed relatively low performance, 33%. We think this is a phenomenon that occurs because the positive sample ratio in the data is relatively low. It was approximately 11%. We compared the model performance with the dummy classifier that predicts randomly. Consequently, HMM-based model was about 1.7 times higher than the dummy model. So we could know the hidden Markov chain hypothesis was true. It worked. Conclusion. In this paper, we confirmed the fact that observation of past life log sequence data is effectively helpful in predicting the upcoming depressive episode. The value of our study is that this is a real-life study for long period of time and for many mood disorder patients. And in the future, We think it is necessary to conduct additional robust hypothesis verification by implementing various modeling techniques other than HMM.